Hello everyone. In this video, I'm going to walk through these questions. Question 14 of part 1 of the homework exercise that I have given to you, RF technologies. So the question asks you to design a step impedance filter. And this filter is a Butterworth filter. Only Butterworth filter has maximum effect passband. The cutoff frequency is 2.8 GHz, and the attenuation at the stop band is 20 dB. The stop band begins at 4.76 GHz. The reference impedance is 50 ohm. The high impedance line is 120. The low impedance line is 15. So these are the information that is given to you. Now, you need to determine the order of filter first. The order of the filters can be found from some of the details like the stop band attenuation, the cutoff frequency. So I'm going to switch you back to the whiteboard mode. Okay, you are now looking at the whiteboard. Okay, so what is given is the cutoff frequency, 2.8 gigahertz. The stop band attenuation, 20 dB, the stop band gain. The pass band is not given, but you may have shown is the corner is about minus 3 dB. The corner gain is minus 3 dB. And the stop band frequency, 4.76 gigahertz. The characteristic impedance, 50 ohm. The high impedance line is 120. The low impedance line is 15. Okay, these are the details. So you need to use the formula specific to Butterworth filter to determine the order. So I'm going to do it 1/2 and then log 10 and then 10 AS minus 1 AP minus 1. So this is the formula 1.8, actually 2.8. So you need to substitute the value. So in this case, I will just do this 10 0.1. AS is minus 20. So minus minus become positive. 0.1 minus 3 times minus become 3. So if you do it very carefully, you will get the value 4.33. 44. Of course, the order should be an integer. So you might just assume it is equal to 5. Now, the next thing that you need to do is to use the prototype table to look for the filter gains at each stage. The filter, according to here, uh, has the order 5, so there will be 5 sections. So G1, G2, G3, G4, G5. And according to the table, this one is going to be 611A03. And this one is going to be 1.61A03. And this one is going to be 2. And this one is Murad 0.610V8. So the next thing is to apply the formula to determine the length of each section. The length of the first section is going to be G1 and then GH. So 0.61A03 times 50. And then high impedance. So from what I can get here, it should be 0.25. 0.5. This is equivalent to 14.75 degree. Okay, then you just carry on with the same process. The next day will be based on a different formula, G2, and then the characteristic impedance will be in the bottom, and then 1.61A03 times 15, and then 120. So from what I can get here is 0.48454, and the angle, the length is okay. So beta 3, the formula will be the same as the first one. The value here is 2, and you will get 0.833, and this will give you 47.74 ohm. And I can tell you G4 will be the same as G2 because the series should be symmetric about the midterm. So 3, arrow 4 should be exactly equal to 27.81. And similarly, 5 will be exactly the same as the first one. Uh, then it's basically done. What you need is to uh, draw the diagram. So the first section will be 14. The second section will be 27. The fourth section will be a long one. So you have 120 ohm, 120 ohm. Oh, sorry, should be 15 ohm, 15 ohm. Yeah, 15 ohm, 15 ohm. So this one is 120 ohm. And the length here will be according to what you have calculated. The length here, 47.7 ohm. The length here, 27.81 ohm. Okay, so this is the end. Um, this is the schematic of the filter. If you have any further questions, please you leave your questions to the comment section of the video. Uh, the step impedance filter will be more or less the same everywhere. So this is the answer for question Q14. Okay. Uh, if you don't have any question, then thank you. Bye bye.